Yeah, I don't know, because it's been a couple principals since when they, like, so maybe not, I don't know. Because our principal started isn't there anymore. Alright.
Maybe he got brutalized and got arrested.
No, now he's the superintendent in Grad.
Oh, never
So
mind.
no, he got a better job.
That's what I thought.
Okay. So we are actually kind of putting a couple of sections into one, but we won't do every single aspect of that section. So kind of putting a few things together. We're going to talk about factors today, learn a few different properties, and like talk about whether or not, someone's got his name taken, if something is a factor or a multiple of something. And those are just words we use a lot in math, but I want to make sure we define them. So, because like I said, we use integer, factor, multiple a lot, and maybe you don't even remember what the difference is. So, integer, do you guys know what an integer is?
No.
Positive, negative, no. Did you just say that?
Yeah, so positive, negative, whole number.
What did I say?
So they're kind of your counting numbers, like. So not a decimal.
Let's stare.
All right, so then factors versus multiples are kind of opposites of each other. So what's a factor, what's a multiple? Kind of difference between those two.
Stone. Answer the question.
Stone.
That's
With your
Yeah.
crusty jeans.
What's the difference between a factor and a multiple?
Khakis.
What's the difference between a factor and a multiple, Stone?
Yeah, stone.
Yeah, stone. Let's
We use these words all the time.
Factor, you add stone.
Yes, Stone.
Let's go
Factor has nothing to do with adding.
What?
Nice try though. Not adding.
Factor is like something like, it's like,
You multiply. It's the things you multiply.
So, it has to do with multiplication. They actually both have to do with multiplication. They both have to do with division. So we just kind of got to sort that through that. So a factor is a number that can divide into another number evenly. So like 3 is a factor of 12 because 3 divides into 12 evenly. So divides into another number evenly, which means there's like no remainder. There's it's a whole number. And I'm going to use the word remainder because we're actually going to discuss remainders quite a bit today and over the next few days. So divides into another value with no remainder. So 3 is a factor of 12.
whoa. Just kidding. I got a lot of energy in this period. That's in my next period, I'm gonna pass out.
So 3 is a factor of 12. So multiple is kind of the opposite, but at the same time, I feel like it's a little bit harder to explain. So it's kind of flipping that. So like 12 would be a multiple of 3. So it's a number you can get from multiplying another number. So it's usually the same size or bigger than the other number. I have to see if I have a better way to say it than what I just said. So I don't think they have it in here. Like a good definition. So a value that another number can become by multiplication. So 12 would be a multiple of 3. Because 3 times 4 gives us 12, but that means 12 is a multiple of 3. Now it gets a little more confusing when we talk about this algebraically, so that's what we're going to do here in a second. Are the following true or false? But then we're also going to kind of show how we know that they're true or false based off of, or kind of do a little bit more explanation. So are the following true or false? 3x is a factor of 12x to the second y minus 30x. So can 3x like divide into that with no remainders? Yeah. So I heard yeah, so I'm assuming that means true. So true. How would you show that? There's probably a couple different ways you can show it. You could divide by 3x. So I could take 12x to the second y minus 30x and divide by 3x. I could show that I could divide that and it works out that I'm able to do that. I can distribute this. This would be 4xy minus 10. Okay. Anyone have another way to explain it? Yeah.
Multiply 3x by something to get.
Yeah, so I can take 3x and multiply it by something to get that, and so what would you be multiplying by? Do you see it? So 3x can be multiplied by something to get to that. What's the thing we'd be multiplying by then? Yeah, it would be the 4xy minus 10, that if I'm taking 3x, I can multiply it by 4xy minus 10, and it's going to equal this. And so either one of those is a great way to explain it, that I can multiply two things together to get that, or I can divide by it and it works out just fine. Alright, so the next one says 11m to the 5th n squared is a multiple of m to the 4th n to the 3rd. What do you guys think? No? So what's wrong with it if it's no?
There's no
There'd be a remainder on n if I tried to like divide them. So like that I couldn't multiply this by something to get that. I could multiply it for like the first half. Like, so if I took off the n's, it would be okay. I'd multiply by 11m, but the n I would have to like lose somewhere one like in the scheme of things here, and that doesn't work. So this would be false. Because there's no number like m to the 4th, n to the 3rd that I can multiply that by, other than using like not integers that would equal this. Now you might say, well, yeah, you could have used a negative exponent. That no longer becomes a factor or multiple then, because technically that's not considered an integer. It has to be an integer, a nice whole number. As soon as we throw those negative exponents in, it technically becomes like a fraction. So it's no longer an integer at that point. Okay? So the explanation is just maybe showing a little bit of work that goes along with it as you're doing these. Okay. So the degree of a polynomial. So we're going to talk about degrees here in a second. Maybe just looking at this first one here, like just look at this first half of this polynomial here. Does anyone remember how to find the degree? Something you guys used in algebra and algebra 2, it just maybe escapes you a little bit right now. Degree. That first half of that first problem. What do you think the degree would be?
The largest exponent.
It's the largest exponent among any of the terms. that should be any term. I am. I'm nervous. I'm already nervous.
She's mine though, it's like she's the person with the fight.
And I get yelled at, and
You'll do great.
Just yell, just bark at them or
the
something.
crowd cannot yell stuff at me though. Then.
That's
That
the
means, like,
thing.
yeah.
The crowd gets you, but like, don't let them change their mind.
If the other
Unless it's for us, then.
If the other
Yeah, it's for us. Pick
fair,
favorites.
it's gotta be
What?
fair.
I can
That's
go
how
grab my wallet.
that's how you
Hey,
get your students
this
to
is
love
the
you.
playoffs.
You do anything
Yeah,
to
you
win.
can shout
It's
out.
plus sheet.
Yeah, you can go like, you gotta
Yeah.
go.
No.
Can I go get my wallet so I can go to fade?
Yeah, just like start like handing money over, be like, nice call, Mrs. Duffy.
Yeah.
That's our girl making those calls. No.
Yeah, that's our
Math teacher.
Yeah.
Your students will love you.
Well,
We already
It's
love
the ref
her.
like asks you like, are you sure that was out? And be like, well, a squared plus b squared.
So yeah.
I did the Pythagorean theorem. Alright, so, how did this go awry?
I knew it was
Alright,
fine.
yeah. Alright, so largest exponent on any term. So if we were just looking at this very first half of this x to the sixth power would be the degree. So, for example, if I have 7, x to the third, the degree would be 3. And I guess we did talk about degree a few chapters ago with like end behavior a little bit. That's that power on the exponent on the variable. So now these next two problems, I didn't leave you a ton of space, so I hope you're not like spending forever foiling these like 3 times 3. I'm gonna hopefully get you guys to see you don't really have to like do that whole problem to figure out the degree. If I want to find the degree of this first one, this is technically like super foil that I'm be doing first, outer, inner, last, but then I have a few extra little terms there to do. So if I actually wanted to figure out what this was, this would be kind of a pain of a problem to do. I would have to multiply this, I'd have to multiply this one too, and then I'd also have to do this one. We don't have to do all that. Why not?
Just do the biggest.
Yeah, look at those 2 biggest ones and just worry about that. If they're asking for the degree, they're not asking for you to simplify this. They just want to know what the degree is. And because the degree is so important in like higher level math, because it tells us a lot about the equation and what the graph should look like, we care about that degree. So we just need to look at those 2 highest, and I'd be multiplying these together. But we have to remember our rules with multiplication. When I multiply, what do I do with the exponents?
Add.
So this would actually be like a 3x to the 10th. So the rest of it really doesn't matter at all. So this would be degree of 10. Now technically, getting back to what we talked about last chapter and kind of noticing those critical points, that means there could be up to 10 solutions for this. Like that power is a big deal in equations and in graphs because that's how many times it can hit the x-axis. Now why is letter B a little bit different? It's a minus instead of being a multiplication. So what are we doing instead with this one? We're subtracting, and again, we can just look at the biggest one again. I have 8x to the 5th minus 9x to the 5th. I don't see anything else I need to worry about if we're just talking about degrees. So 8 minus 9 is a negative 1. I don't really worry about that. But then what happens with the exponent?
Wait, what about 16?
0.
Okay, so real quick, the 16 doesn't have, we don't have to worry about that because it's not a high, it's the power we're looking at. So the largest exponent. So we don't really care that that number is big. So what happens with the exponents, you guys?
They get done.
0.
Oh, you guys are scaring me.
One.
We're combining
You
these.
add that.
They stayed
They stay the same, thank you. So when you combine like terms, guys, like I heard like 82 wrong answers here. but no, so we don't do it. Yeah, just sorry, you might have said it like 8 times, but I kept hearing all the wrong answers really, really loud. So we would.
You didn't say it.
Kids.
Right. No, you didn't.
All your loud answers, loud wrong answers. Got okay. So.
I didn't say I said it right. I just said he said it wrong.
I didn't know why.
Okay. And I might have heard it, but it's sometimes when I hear again those wrong answers, they come out a little louder, I think. So this just a degree of 5. In a problem like this, we just combine like terms. If you were curious about the rest of it, this would be the 7x's to the third actually would cancel because it'd be negative, negative become positive. And then just to be 58 minus 16, so we get like 42 for that, and just to be 42x. So if you're curious about combining like terms there, especially now that I hear you guys say that you're going to cancel those exponents, you're scaring me a little bit. So I figured I'd mention the rest of that. All right, so there's a couple of properties we're going to talk about with factors. Now, being able to like rattle these properties off like word for word is not something I'm going to make you do, but at the same time, being comfortable with that this idea works is kind of important to know. So I'll try to write it out in a way that's easy to hear. So it's basically saying if, we'll write this up here. So if A is a factor of B, so some value of A is a factor of B, kind of the idea, like 3 is a factor of 12. And B is a factor of C. So like 3 is a factor of 12, and 12 is a factor of 24. What do you think we could conclude from that? The word transitive in there might be important.
A is a factor.
Oh,
of
look
C.
at you guys. You sound like a cute little like like I like planned that.
That was kind of creepy.
And we just recorded it. It's almost like
Let's play it back.
I know we can.
It's like that.
We all said it like the same time, the same tone.
It was like yeah, it's like church. All right, so A is a
That's not
factor.
scary church.
Yeah, that just rattles off math properties. Oh man. All right. The fact, and so that obviously makes sense to you because you came up with that on your own. Good work. All right. The factor of a sum of integers is the next one, and this one's kind of bizarre that this works out this way. So in this case, change this up a little bit. And again, we don't have to necessarily be able to rattle these out just so we be comfortable with them. So A is a factor of B, again. Now this time A is also going to be a factor of C. So like A is a factor, like 3 is a factor of 12, but 3 is also a factor of 9. The sum, what it's basically saying is that if I add those two together, the B and C together, A is also going to be a factor of those combined, which is kind of a strange one. But once you see it with numbers, I think it makes sense. I'll show you guys an example, and then we'll take a break.
Yay.
Okay. Let me just show you a quick example of this. Yeah, we can go outside.
Should I do my makeup for today? Because it's gender swap.
Anybody need a wig?
That's what the theme is?
Yeah.
Oh my gosh, Peyton, I'm
wearing-
like, I told Peyton needs to come to the game and do the dress up thing. I had no idea what the theme was
I'm
when I told
wearing
him that.
tights.
Because we're both working the game, I'm like, Peyton, you should come to the
He's
game.
both, what's he doing?
He's actually announcing.
He is?
Yeah.
Awesome.
He's like, what do I have to, he's like, do I get to announce like Spike? And I'm like, no, you do not get to announce
I'm gonna do like a Bisco, bro. I'm gonna take my high jump.
Do you need scrunchies?
Yeah.
I have some scrunchies.
Alright. Okay, so we need a break.
Well, if
Alright.
you wear a wig, you can just